Okay, last one. This is practice problem 6, lesson 9.3, part E. So we've got negative 2x squared equals 3x plus 12, and we want to solve that bad boy. So our first step, again, is going to be to get it in standard form, and that is set it equal to 0. Now the 0 does not have to be on the right-hand side. A much kinder way to get this thing set equal to 0 would be to add the 2x squared to both sides. In other words, make it equal to 0 by saying 0 is equal to 2x squared plus 3x plus 12. Okay, so we are still in descending order, which makes it easy for us to identify that is A, that is B, and that is C. So that tells us that we can go ahead and simply plug those numbers into the quadratic formula, which says that x is going to be equal to the opposite of 3 plus or minus the square root of 3 squared minus 4 times a, which is 2, times c, which is 12, all of that divided by 2 times a. And again, the pesky little critter in here is this piece, the part underneath the square root. And again, I said a couple times, that's called the discriminant. So we're going to let the calculator take the hit on that. We'll let it go ahead and do the work for us. So that's going to be parentheses 3 close parentheses squared subtract 4 parentheses 2 close parentheses open parentheses 12 close parentheses, and we end up with negative 87. Okay, which back here at the ranch tells us that what you have got is negative 3 plus or minus the square root of negative 87 divided by 2a, which was 2 times 2. I can't help put the a there, can I, huh? So that gives me back a 4. All right, so what that tells us at this juncture, we're not quite ready for this yet because I've got the technology yet, is that this is a complex solution. In other words, we have complex conjugates for our zeros, but we're not at that point yet in the book. So what we say is no real solutions. There are solutions, they're just not in the real number system. And we will learn quickly in the near future how to deal with non-real solutions, but not today. We're going to start talking about complex solutions or complex number solutions. So how do we verify that on the calculator? Well, we'll come back into our y equals, make sure you've got 2x squared plus 3x plus 12 in y1. If you try a zoom and a standard, what you'll see is absolutely nothing. The graph will not show up on your view screen, and that's because if you think about it for a second, our vertical intercept or our y-intercept is at 12. We put a 0 in for the x's here, those will both drop out and we'll be left with just a 12. So let's go back into our window here and let's go move up the y max a bit so that we can see at least that vertical intercept. So I'm going to just put a 20 in there. We'll just go for 20, and then let's make the scale 5 and hit a graph. And yep, there we go. And that's good visual evidence that there are no real solutions, because the number of times it crosses the x-axis is the number of zeros you have. We have no zeros here. Okay, so let's go ahead and get ourselves a reasonable facsimile of that graph here, which looks something like that. And this being our x-axis, this being our y-axis. So we're going from negative 10 to 20 and negative 10 to 10. And as far as simplifying this, you don't go any farther. It's done. Okay, well, hopefully that helps. If you need any further explanation on any one of these problems, be sure and reply to this posting or send me a message via the message link, and I'll see what I can do to clean it up a little bit for you.